Alright, so we are going to talk about scale drawings and scale factors today, which are related to topics that we've covered before. Kind of bringing geometry back in with what we'll see in a minute here. So today we're going to talk about using scale drawings and how to find a scale factor. And you see the vocabulary we're going to use a lot to do with scale. So you're going to be filling in your notes as we go along. If you need time to think, time to write, time to whatever, make sure you pause the video and think about what you're looking at. So when we look at scale drawings, and scale drawings could be a model or something drawn, could be something 3D, but a scale drawing is a drawing that uses a scale to make an object either smaller or larger than the real object. So our purpose in having scale drawings really is to use it for something larger or smaller than what we can maybe fit on a piece of paper. So when you drew in science class this year, when you drew atoms, an atom is much, much, much smaller than the drawings that you guys did. And so that would be an enlargement. Or let's say you were going to construct a new building and you needed to lay out what exactly was going to happen. You would use a scale drawing. So there's lots of uses for scale drawings. Those are just two quick examples. But they help us kind of see things in a more friendly size than what they may actually be at. So when we're doing scale drawings, the scale itself is the ratio between two sets of measurements. So a scale helps us know basically how big something is in real life compared to how big something is looks like on our drawing or our model. So your scale is the ratio between the two sets of measures. So you can see here we have our measures would be when we include units, inches, and feet. Maybe on a map we would, so like a map of like highways and things, maybe we would have miles. But the scale factor then is the specific ratio that's used to look at this. We're going to either make it bigger, enlarge it, or we're going to make our figure smaller. So when you're writing your scales, and this is the important part, it's always written to where the first value, and remember we can write a scale with this comparison, this ratio. We can write it multiple ways. One way is with the word 2, one way is with the word colon there, and the other way is the using a fraction. So remembering at the bottom here, ratios are always going to be written as the model number compared to what we see in real life. So you might write your ratio this way, or you might write it as a fraction. But the important thing to note is, and you could write this, and notice anything underlined is things you should be adding to your notes. But your model is the first number, what you see on your model, and then what you see in real life is the second number. And that's always the way your ratios will be written. So before we get to some actual problems, and if there was anything that was important, this would be the most important thing. So you may want to add this into your notes. The real life number being second, the model being first. Before we get into some problems, we're going to try and do a little practice here for how we're going to solve our scale problem. When we solve for scale drawings, and maybe we have a figure and we want to know how big is it going to be on the map. How big is it going to be if we're going to scale something up, or we're going to scale it down and make it look accurate. We're going to use proportions, which is this is the throwback to things we've done in the past. We're going to use proportions to figure out what our dimensions need to be. So I'm getting my calculator here ready to go because we're going to review solving proportions. And to solve a proportion, if you remember, we have the proportion here. You're going to cross multiply. We're going to take 6 times 0.7. So 6 times 0.7. And then we're going to take that answer and divide it by the number here. So this was called cross products. We did this a whole bunch at the beginning of the year. So we're going to take 6.07 divided by, 6 times 0.7 divided by 1.2. And the answer I get is that our value that we're missing here is 3.5. So we're going to set up proportions, which we did at the beginning of the year. We're going to set up proportions and we're going to solve for the parts that we do not know. So there's two types of problems on this video. There's the I do problems and there's the you do problems. For the I do problems, you're going to kind of follow along with me, work along with me on your page. For the you do problems, you're going to pause them before and try them on your own before listening to how to go through the answers. So here we see a map. This would be obviously much smaller than it is in real life. This is a map of Florida, and it says what is the actual distance between Daytona Beach and Florida. So I'm going to write a reminder to myself here that the model is the first number, the actual is the second number as far as our comparisons. So it says the distance on the map is about 1.5 inches. We might ask you to measure sometimes, but in this case, I'm telling you what the number is. So this would be, which number? This would be the model or the actual? This would be the model. The model is the map. So this would be the number that we have for the model. So what we need to use is a scale that tells us, and you might see it on the map, a scale that tells us what is the scale that's being used. If you see this right here, this is telling us on the map what does a certain distance, what does a certain length measure. So we have a scale that is, and you're going to be writing this along with me on your page, we have the model is saying that 1/2 inch on the map is the same as 17 miles in real life. So here's the model, and here's, I'll change this to real life. So what we want to do is set up a proportion with the information that we know. What do we know? We know that the actual number, or we don't know the actual number. We're trying to figure that out. We're trying to say what is the actual distance. We don't know that, so what do we do when we don't know the number? That's where our variable is going to go. So if you remember, when we set up proportions, we want real life compared to real life. We want the model compared to the model. That's how we know where to place our numbers. What do we know about the model? We know that it's 1.5 inches. All right, so now that we have our numbers set up, we can cross multiply. We'll do 1.5 times 17, and we'll divide it by 1/2. So when I do, on my calculator, 1.5 times 17 divided by 0.5, I get that the answer is 51. Okay, so when you answer this question, think about what you're being asked. You're being asked what's the actual distance between Daytona Beach and Orlando? What units are the actual? They would be miles. So this would be 51 miles. So when we're doing these problems, you're going to do two things. You're going to look for the scale, and that's going to be kind of the beginning piece. And then you're going to say, okay, what do I know? So let's do this second one together. Again, this is an I do, so you're going to kind of follow along. So we have a graphic artist creating an advertisement for the cell phone. She's using a scale of 5, so our first step is always our scale is 5 inches compared to 1 inch. Now the confusing thing on this is that we have the same unit. So it says, what is the length of the cell phone on the advertisement? Okay, so we want to think, is this going to be the model, or is it going to be real life? The advertisement itself, we're looking for the model. Okay, so this is my scale, and I'm going to remind myself that scale is model over actual. This is real life. So 5 inches on the model, so it must be that they're trying to make a big model, because 1 inch in real life is being taken to 5 inches on the model. Maybe they're making some kind of billboard, so they want to make the cell phone look really large. So on my other ratio here, I've got to think, what do I have? I have the 4 inches here. 4 inches is the cell phone in real life. So I'm going to line that up with my actual value, which goes in the denominator. What do I not know? And again, say my question here, I don't know the model. So I've got my numbers lined up. Let's cross multiply. We have 5 times 4, and we would do divided by 1. 5 times 4 is 20, divided by 1 is 20, so 20 is the value I'm missing. And what would 20 be? Looking at my units, look back at your units in your scale, that would be 20 inches. So that cell phone is going to be 20 inches long, which if you get a ruler and look at that, that would be a pretty large cell phone. So maybe not billboard, maybe more like a magazine page. I'm not sure. That would be a pretty big ad. All right, so this one is a you do, which means you're going to try this one on your own before watching the answer. I'll go through the answer a little more quickly than I did in the other problems. If you need to, you go back and you look at the other two. You can rewatch the video, pause, rewind. But at the very least, you're going to pause right now and you're going to try this on your own. So if we look at this, it's saying we're painting a mural, and she's using the scale of 4 inches. Remember, this is the model number. This is the actual number. That's real life. So I'm going to go ahead and put my scale, 4 inches compared to 1 inch. Model compared to actual. Real life. Whoops. I don't know why that did that. Model compared to actual. Okay, so we're going to set up our proportion. It says, how large will the mural painting of a rose bloom be if the actual height is 6 1/4 inches? So we have the actual number. The actual number would be 6 1/4 inches. It says how large will it be on the mural. So that's our x. That's what we don't know. So we're going to set up our proportion and we cross multiply. 4 times 6 1/4. And that would be divided by 1. And that value would be 25. Make sure that if you are using your calculator, which you should be, that you can get that value from your calculator, that you know how to type this number in to your calculator. So our units, looking at where my value is here, our units would be the same as the numerator here. It would be inches. So that would be 25 inches on the mural is how big the rose bloom will be. Okay, we have one last piece to finish up, and that's the idea of the scale factor. Now, when we look at the scale factor, this is our scale. When we look at a scale factor, the difference is that we're not going to have those units included, and it's just a number-to-number comparison that we can use for any set of units. So when we do a scale factor, when it says to find the scale factor, we're going to write our ratio. Again, this is still model to actual. But when we do a scale factor, what we need to do is pay attention to the units, and we're going to do some simplification if possible. So when we look at this, what we want to do is make sure that our units are the same in both our numerator and denominators. So if we have inches and feet, the easiest way to do this would be to change my feet into inches. How do I change feet into inches? Well, there's 12 inches in 1 foot, so I'm going to multiply that by 12. I get that this is 72 inches when I do 6 times 12. So my scale factor, if I go inch to inch, I can actually use this for any measurement, whether it's inches, feet, etc., because my units here, like we've done with simplifying, is going to cancel out. So when I say we'll find the scale factor, I want to look at those units, and my scale factor, again, is still going to be model compared to actual, but it's going to be no units included. I want to make sure that my units, so this is my answer, my units are canceled out. They had to be the same first before I could move on. So you're going to try this one. It says you do, so you're going to pause and try it. But just to finish this off, you have model compared to actual. We want to make those into the same units, so I'm going to keep my inches here. I'm going to change my feet into inches, which means I do times 12. So this is 36. So my model is or my scale factor is 1 to